Hi, welcome to this video, and in this video we will understand that how exactly do we represent different trigonometrical functions in different quadrants. Because since our childhood in the school many a times we are told that in this quadrant this function is positive, this function is negative, but we hardly know the reason. Let me quickly remind you that what exactly I'm talking about. This is called the first quadrant, this is called the second quadrant, here we have the third quadrant, and here we have the fourth quadrant. We must understand that to the right we have positive x-axis, to the left we have negative x-axis, upward we have positive y-axis, while downward we have negative y-axis. Now in the first quadrant, because it lies between the positive x-axis and positive y-axis, so both x and y coordinates are positive, while in second quadrant, since x is negative and y is positive, so we write likewise, x is negative, y is positive. In the third quadrant, x and y are both negative, while in the fourth quadrant, x is positive and y is negative because it is between positive x and negative y-axis. Now, let me quickly just share with you that in my childhood I was taught this trigonometry, and I was just simply made to remember that here we have all positive, here we have sine and cosec positive, here we have tan and cot positive, and here we have cos and sec positive. So what do I mean by all positive? That means whether you calculate the sine between 0 to 90 degrees, or cos between 0 to 90, or tan between 0 to 90, that means all the function from the range of 0 to 90 degrees will always be positive. Alright, so before I say that all the positive, how exactly the angles are measured? So that's again an important thing. The angle is always measured from the positive x-axis in anti-clockwise direction. That means when we say sine 30 degrees, we are simply calculating 30 degrees in the clockwise direction. When somebody says sine of 270 degrees, that means 90 degrees, 90 degrees, 90 degrees. So 270 degrees is calculated this way counterclockwise. So when a question ever says that we have to find out sine of 315 degrees, we must understand that the angle is being calculated from positive x-axis in anti-clockwise direction. So far we have calculated 270, and when we add 45 more degrees, that means the line will look like this, and for this particular point we are calculating the angle in the anti-clockwise direction. If sometimes the question says that sine of 425 degrees, then you need to understand that this is same as sine of 360 plus 65 degrees. That means 360 degrees first, this one complete circle has to be covered. This is 360 degrees plus 65 degrees. That means now we have a line like this, and for this particular line we are calculating the angles. So while we say that, simplification of them requires us to understand that in which quadrant which trigonometric function is positive. If we want to remember, then we need to remember that this is Stc Rule. A stands for all positive, S stands for sine and cosec positive, that means the reciprocal of sine. T stands for tan and cot positive, while C stands for cos and sec positive. However, let me quickly explain that why exactly this thing happens. So let's quickly understand first of all one thing about the unit circle. Unit circle is basically a circle that represents all the angles on the xy plane, such that we can see that which angle lies where. So if we have 30 degrees, that means 30 degrees lies here. This pi by 6 is the radian representation of 30 degrees. Similarly, 45 degrees, 60 degrees, 120 degrees means anti-clockwise direction 120 degrees, 135 anti-clockwise 130 degrees. Also, we need to understand that the unit circle means we are considering a circle which has radius 1, and these coordinates are identified based on the radius of the circle, which is equal to 1. So for example, when we say that sine of 30 degrees, right? So let me just quickly note it down here. For example, sine of 30 degrees is equal to the perpendicular over hypotenuse. Now here we understand that this is the perpendicular, this is the hypotenuse, and hypotenuse is equal to the radius. So if we say the hypotenuse is equal to 1, which is the radius, then perpendicular will be equal to 1 multiplied by sine of 30 degrees. Sine 30 degrees, from the previous table we can see that it is equal to 1 by 2. So the perpendicular becomes 1 by 2. So that means we understand that the y coordinate of this particular point is 1 by 2. And using the same principle, if we use it like cos 30 degrees, we understand the base. For example, we can say cos 30 degrees is equal to base over hypotenuse, and here we once again know that hypotenuse is equal to the radius. So we can say that base is equal to 1 multiplied by cos of 30, and cos 30 is equal to root 3 divided by 2, and that's where we have got this particular distance equal to root 3 by 2. Likewise, for every respective angle, we have identified the coordinates of this unit circle. Now let's proceed. Now we want to understand that why everything here is positive. For example, I'm just talking about these three things: sine, cos, and tan. Why? Because the cot, sec, and cosec are just the reciprocal of them in the reverse order. So sine theta, if we calculate this angle to be theta, then sine theta is given by perpendicular over hypotenuse, cos theta is given by base over hypotenuse, and tan theta is given by perpendicular over base. Here the perpendicular is positive as well as the base is positive. Here the perpendicular is positive as well as the hypotenuse is positive. And since everything is positive, therefore all three of them are positive, and therefore the remaining three, which are the reciprocal of them, are also positive. Now let's understand what happens when we move to the quadrant 2. In quadrant 2, suppose if we were to calculate sine of 120 degrees, then sine of 120 degrees means we have to calculate for this angle 120 degrees. It is again the perpendicular over hypotenuse. So the perpendicular is actually this particular line, but since the y coordinate in this quadrant is positive, so the perpendicular has a positive value. But if you see the hypotenuse is also the positive values, because the length of hypotenuse is 1. It's only the perpendicular or base that can be negative. Hypotenuse can never be negative, so that's always positive. So sine theta is positive. But let's quickly understand what happens when we look at 120 degrees of cos. Then cos 120 degrees is base upon hypotenuse, and here the base, that means the x coordinate, you see the x coordinate here is negative, and for that reason when we say base upon hypotenuse, base is negative while the hypotenuse is positive, so the resultant is negative. Similarly, when we look at tan of 120 degrees, that is perpendicular over base, and we already have seen that the perpendicular here, that means this line, the y coordinate, is positive and the base is negative, and therefore the tan theta is also negative. That is why we say that sine is positive here, and if sine is positive, then cosec is also positive and everything else is negative. Now let's come to the third quadrant. In third quadrant, what happens is that if we were to calculate, let us suppose sine of 210 degrees, then sine of 210 degrees will be calculated based on this particular coordinate, and sine theta is equal to perpendicular over hypotenuse. Hypotenuse is always positive, but the perpendicular here is equal to this particular line, and since this particular distance in the third quadrant, that means the y coordinate of the third quadrant is negative, therefore this entire sine 210 degrees becomes negative. When we look at the cos of 210 degrees, that is equal to base over hypotenuse. Hypotenuse is positive, but the base here, that means the x coordinate here is also negative. That means the cos theta is also negative here. But if you look at the tan theta, what happens is, because this is perpendicular over base, and since the perpendicular, which is equal to the y coordinate, is negative, and the base, which is x coordinate, that is also negative, so the two negatives make it positive, and for that reason this house is positive for tan theta and cot theta. While if this particular quadrant is looked at, the fourth quadrant, in that we can see that sine of, let us take 315 degrees. So for 315 degrees I am taking this quadrant, sine 315 degrees, that means this x coordinate will be this distance and y coordinate will be this particular distance. So we can understand that this y coordinate is negative but the x coordinate is positive. That means if we take, this is the perpendicular and this is the base, or you can call it the adjacent, this is the opposite, and sine theta is equal to the perpendicular over hypotenuse. The perpendicular here is negative, hypotenuse is positive, so the result is negative. Similarly, let's look at cos of 315 degrees, that is base over hypotenuse, but base, which is this part, x coordinate, is positive here, while the hypotenuse is positive always. So this is house of cos, cos is positive, therefore sec is also positive, which is reciprocal of cos. And when we look at tan theta, that means tan 315 degrees, then we say perpendicular over base, but the perpendicular is negative while the base is positive. We have seen perpendicular is this y coordinate, which is negative, while the base is x coordinate, that is positive. So the resultant of tan is negative in this particular house. And that is the reason why we define that in the first quadrant all of them are positive, in the second quadrant only sine and its reciprocal are positive, in third quadrant only tan and its reciprocal are positive, while in the last quadrant cos and its reciprocal is positive. So that's one of the reasons. We will also find out this by way of another graph in the later stages. But I hope this could make sense, that why exactly in the first quadrant we have all positive and in the respective quadrant there are some positive and some negative. Thank you so much.